So again, I think some of you have just come. So good afternoon. My name is Yashraj, and today I'm joined with Smile. We are the volunteers for the Bangalore JSLovers community. We are having this mega reboot after a long pause, and we have volunteered to actually revive this community and bring all of you together. That's what we do. And yeah, so welcome you all for joining us today. And yeah, so this is this is my, what do we say, like geo mapping. I'm which we have done geo. All right. So the founder Neha, she started this community long ago in Delhi, and then it's expanded to New Delhi. Outside New Delhi as well, we have Bangalore and Mumbai chapters already active, and Pune and other chapters are also going to start soon. So we have it's a pure non-profit community where anyone can come forward. You can apply to be a speaker. We have four. We have a set of four speakers today, a stellar set. And I hope you all will leave this room learning something new and um, having met at least three to four, 3 to 5 or plus maybe new members, new connections you have created at today's meetup. So all of this is for the community, by the community, but we would love to have support from the organizations you work for. So please feel free to reach out to us if with the help of the venue and any other everything which we will receive, it will go back to the community. We do have some organizations which do support, but yeah, so that is all. And JavaScript is on the rise, continuously meteoric rise, right, as we know. And JSLovers, what sets it apart from other communities, it's there are no boundaries. So anything related to JavaScript which you think others should know, others should learn, you can come forward, apply as a speaker, and we would love to have you joining us. So moving forward with today's session, little bit about our speakers. We have Vivek, we have Tanisha, we have Kumar Prince, and we have Tapas. They will be hosting. They will be talking about the topics which I hope all of you would enjoy learning about. And yeah, we have a Discord server. Anyone who is already active on Discord, by the way? All right, that's great. So you can join this. How many of you are interested in aviation? Just by any chance? Aviation enthusiasts? Anyone here? Okay, 1, 2, 3. No, I'm just trying to understand how many of you are into fitness. Anyone? Oh, that's great. That's great. So, how many of you are ready to come Kabban Park 8 a.m. in the morning? Anyone? All right. So we are just doing a live check that if we do a meetup, we call you at the Kabban Park and we do it. We start the meetup at Kabban Park and we after a warm up. How many of you will turn up? That's it. But yeah, you can join us. That's what makes the community. It's the people, right? And as I mentioned, 6,000 plus members on Meetup across different chapters, and 500 plus sessions have already been done, and pure community work. So just imagine the massive impact which is having. And that's thanks to you all. Some of you, anyone who is an OG JSLovers participant or contributor, anyone who have attended before the pandemic the events which we used to do? No one? Okay, everyone is brand new. This is this is the mega reboot we are talking about. All right, so that's great. But yeah, we have a code of conduct that please be respectful. All of us are here to learn, share, and grow. So please do not disrespect anyone, be it speakers, be it venue, um, be it the whole. I hope you want, but yeah, and also the technology, right? How many of you uh, have been into a banter or a conversation, heated conversation? No, this JavaScript library is the best. Anyone? All right. So every technology has its pros and cons. No technology is perfect, but we all are here. So please please be respectful. Let's not disrespect anything else, right? There are end of the day, users don't care, do they don't care, right? Users, they what they want to do is to have a good user experience. And yeah, so we as developers, we can talk about the technologies which we are using and evangelizing. And yeah, so it seems my laptop is giving me indication that get off the stage and let the first speaker on board. So with a huge round of applause, please join me in welcoming Kumar Prince as our first speaker. Yeah.
Okay, hi. Good afternoon, everyone. Okay, fine. So today I'm going to talk about testing strategies for creating robust and reliable React applications. So, like many of you have been knowing about the React.js, right? Writing the applications with that and all. So, and many of you might not have been writing the test cases, and some of you might have been writing. So, I want to talk about why should we write unit tests, right? Okay, so let's suppose you are a chef, right? You have created a delicious food and all, and you think it is perfect. Okay, and then after that, like you serve it to your customer. Okay, so then after what happens is like maybe something might have been missing, like salt or some spices, and it's not as good as what you have thought. So like the same way, right? When we are creating the front end application using React, so then what happens is like we have been writing a lot of features in that, right? Mostly we work in an enterprise application, and then we have been writing the test. And what happens is like some test may be breaking the feature of some other components. And there, what happens like if we try to do it like testing it manually, so it can't happen, right? It will be having a lot of test cases, and then you can't just send it to QA and make them test everything, right? Something might have been missing and something might break in the production, right? And also it increases the confidence in the application, like whenever we change something in the code and we just run the test, and if it is working fine, right? So then we get a surety like, okay, my test is good, and then after like I can really deploy this code to the production, and my customer can use it without any facing some issues and all. And also it works like a documentation, like uh, what happened like someone joins your team, right? And you are in the and they don't know much about code. He's exploring all the code base, right? So they can't just see everything and figure it out like what this code is supposed to be working on. So it works like a documentation, like he can goes to the test cases, and they can get to know what is supposed to uh, do. Okay, so that's why we should. And generally like developers write three types of test cases mostly. One is like unit test case, integration test case, and also E2E sometimes. So in unit, what happens like in a React, right? You are creating a components, and then you are just testing that component, like that is working as expected what you have wrote. So you are testing the unit test, testing that specific component in isolation, and just checking for the behavior, it is working fine. And then after we have the integration test case. So in React, we might not have been writing just one component, right? We have been writing different top component and integrating that with each other. So in that, we just make sure like all that like components are flows working fine and they are working properly. And then goes to the E2E. So E2E is a test case where we write the test cases for like end to end. Like let's suppose you're writing the test case for Flipkart or Amazon, right? So you just sign in, you just select a product, go into the cart and then place the order, everything. So that we can write it using E2E. And yeah, so mostly like in test block, right? So whenever we write test cases, we have like this test anatomy which we have to check. So first of all, we render component which we want to test. It can be a function also, whatever like we have written, and we can just call it. And then after, we just find the elements in the DOM what we want to interact with. So our components will be having different kind of elements, like it can be which have the paragraph, right? It can be heading, it can be buttons, or like different things. And then we interact with those elements. It can have the input, it can have the buttons and all. So we'll have to simulate and we'll have to figure it out. Okay, so if the that is working fine, so after interacting with that, we just assert that the results are working as expected. So let's suppose some DOM is there, right? And you are expecting like in the heading, it should be written like fine, like it should be okay. This is working fine, or some component name is there which you want to test, and that should have a button which should be working something. So that thing we can expect, and we'll assert it that it is working fine. Okay, so we have like different tools to test React application. So we have RTL, we have Jest. So RTL is given out of the box when you are creating your React application using CRA. But since most of you have been like not using the RTL and maybe using some different frameworks like Remix or Next, then you can directly easily install it and work with it. And we have the Jest also. So with the Jest, right, it can be used for different JavaScript framework, and it gives us many of the things like we can mock our function, and we can just make use of it. Okay, so in unit testing, right? So I talked about it already. So we are just testing the component or the function and making sure that is working fine. So I have a code here. So I have like made this application here, and it has something like, so what I have done, this is the main components, and it has two of like different components, child component, which I am importing and passing the uh, state and the set state function to that. So what we can test, right? So in the add input or in the to-do list, right? So we can write the unit test for this component, and for the main component we can write the integration, since there we are oh, okay, sorry. Excuse me. Okay, fine. So you guys can see it, right? One more. Uh, hope is visible. Okay, fine. Okay, so these are for this we can write the integration test, because we are calling two components here and passing the props and the set function here. And for this small components, right, we can write the unit test for it. So generally, like when we write the unit test, which will make a folder using underscore test, and then generally we write it and keep our test there. And for the add input, right? So here what I have written is like first, right? So we can just write the test. So it is a keyword which we can use to create our test, or we can write the test also here to test. So both the keyword works fine, and then after we have to write what this test is supposed to do, and then we pass the callback function. So I told you, right? So first we render the component, then we find the elements we want to interact with. So we have a function in a React testing library called screen, which has a lot of functions. So here in input function, right, you can see like I have made the placeholder here, enter value to add. So I am trying to get that element here with the help of get by placeholder text, and then I can just assert it, right? It should be in the document. Otherwise, how are we going to test it? So it is there, so it will pass, and then after you can see like add button is there to add that component. So I am just taking that button here, like with the help of role, uh, because its name is button, and then name is add. Sorry, type is button. Yeah. So we can also make sure like this should be in the document. So this, since this component has not much thing to do, I have written just one test. But yeah, so for the to-do list, right? So when we enter something and it is getting added to the screen, right? And you can also see like this total items number is increasing, and when I remove, right, it will become 0. So we can test like when nothing is there, then total items should be 0. And also like in the DOM, that to-do list should be empty and it should not contain any of the items. Yeah. So for this, I have written a test here. So here I have created a test suite because it can zoom. Okay. So here I have created a test suite because it contained more than one test. And I have describe is used to is the keyword which is used to create a test suite. And there you can just write a test with the help of it keyword, which has the explanation like what is test is doing. And then after I'm just rendering the to-do list. Okay, so this to-do list doesn't have anything. It is just taking the props and rendering it, and also like removing the items from the DOM. So you can see like I'm taking two props to do item, say to do item here, which is getting passed from the parent, and also like deleting it, and also here I'm just mapping it to the screen, which was getting shown here. So in the to do list test, here now I'm just checking the count because initially it was 0, right? So when I run this test, it should be like total item 0 in the document should be present. And then okay, so like I took this and just tested it out for the initial time, right? But for the second time, right, I want to test like which should have an item on the screen, and also this count should be increased because as what it is supposed to do when it is getting increased. So since it is taking prop, right, I have created a mock data here, like to do data, which has two, which is an array and it has two items, and just added it here. So what it happens like when I rendered this element, right, I pass this to do data to this item, and then I'm expecting like this screen should have the total items too, because two items got added in the screen. And also like you can see here I have written like build the feature and updated the doc here, which should be on the screen. So this is also will be present to the DOM, and it will result as true. And also like I have since that the component is doing deletion also, so I have done like again I have passed the same item here, prop item, and I have passed the function also, because when I click on the remove button, something should be called, right? But it is not going to update to the main item, because this is just a component with a props. It is not doing anything with function. So for this function, right, uh, which is this one. Okay, so here what I'm doing, like I'm doing set to do items. I'm removing one item from here and then setting it. But this will not work here as sorry. Okay. Yeah. So this will not work as set to do items is not the part of this component. It is part of the parent component. So what I have done here is like I have created a mock for this deleting mock function. So with the just dot function, right, you can create the mock of different kind of function, and then you can just assert it like if that function have been called or not, because that is what our main goal is here. So what I did is like I rendered this component, and again same thing, like I'm expecting in starting only, and here I'm just querying the element which should be in the document. And when I click on remove button, right, so what happened like when I write more than like add more than one component, it will have the different it will have more than one. And then I can't just do get by role with that button remove, because every button has the same name for all the items. So I'll have to do get all by role. Okay, so then I can remove it with the help of like, okay, so because here I pass the props which contains two array, and which is getting rendered on the DOM. So I'm removing the first item from here, and then I'm expecting this delete mock function should be called fine. So that's how like our unit test work. And for the integration part, right, so this is the main component here, which has both the item, like add input and this thing, right, which is getting rendered to the DOM. Both the item I have written here, and for this test I have written the integration test here in the todo test.js. So it also has a test suite, which is describing it is a to-do test, and it is rendering the to-do component initially with the 0 items. And then after, like, here I don't need to pass any mock data or anything, because here I can totally test it with the help of user behavior. Like, user can just find the like input box and enter something, and then after add it to the DOM. So what happened is, like, then again I did the same thing, like finding the input placeholder in the document. It is there. Then what I will do is, like, I took the button here, and then after in the input placeholder I have typed the write the tests. Okay, so, and then after I'm clicking on the add button, which will add it to the DOM. And again, like, I have added one more, like, here, like, yeah, complete the feature, and then I have clicked the add button. Then now the total items is increasing. So that is how integration test you can do, is like testing the feature. Like, both the components are separate, but I am checking the flow of the data, if that is working fine or not. Cool. Fine. So same thing. So the same thing was added here in the slide. Like, I have took the snapshot of both the components for the unit test and just pasted it here. And same I have explained for the integration testing, like checking the flow of the two components, and same snapshot I have added. And yeah, so when we are working with React, it's not like we are just working with the synchronous thing, right? We'll have to work with the APIs also, and we'll have to work with, like, yeah, different, like, timeouts, or like set timeout is there, and asynchronous code can be there. So for that also, like, we can test. So I have written one more example here. Like, I have a user component which is getting rendered to the DOM. This is the component where I am fetching, making the real-time API request, and that's why it is getting loaded like in some time, right? It's not directly coming to the element. So when we are writing test for it, and we will just write the same code, right? It's get by text and asserting it, and also it will not work, as it's a asynchronous code which is taking time to render to the DOM. So yeah, so this is the user list. So same thing, so it is just a common like normal component which has the user list, and I am just taking a state here. Okay, and then I'm just in use effect, I'm fetching the function on the when a component is getting mounted. So, and this is the dummy API which I am calling with the limit of 10, and then after just rendering it to the DOM. So what happened is, like, to writing this unit test for this, I have a, like, right now I am testing it with the like real time API. But when we are testing anything with the real time API, right, it's not recommendable, and it takes a lot of time. Because like, let's suppose we are working an application where we are making hundred of calls, right? In some of the feature we are making call or making payments, doing anything, right? So it will actually take a lot of time, and it also increases the cost of the company, right? Because they are already hitting the server every time. So this is not reliable, and sometimes API can fail also for some other reason. So for that, we have to mock the data. So generally what happens is, like, okay, so when mocking thing to mocking thing, right, we'll have to install the different package. So I have the just fetch package installed, which I have done. And then you'll have to set also. So since right now I have not enabled it, it was working with the real time data. So I will enable it, and I'll change it in the user list, because these are the code which is mocking the data here, and I have commented it for now. So okay, so now it will take this data, and also, like, before running this test, right, I am every time before the any test will run, before that, this will reset the mock, so that it will come to its initial state. Fine. So okay, fine. So I have uncommented this code, and again I will try to run this. Uh, okay, wait. Okay, so that's how it runs, and एक second, let me run it again. It is okay. So I'm using the yarn. So test is the command which you can do. So with npm you can do npm run test, but with yarn you can do yarn test. And then it asks, right, if you want to run all the test and only run the fail test, and you can quit the mode also. Like we have different options. So I will do yes since I want to run all the tests. Okay, so you can see, right, all the test is passing except this one. Since like this test is not passing because in mock, right, I have added only 3 data and I'm expecting the length to be 10. Mm, okay, I'll change it and again I'll run. So you can see, right, so it has run all my test, and every test is getting passed, right? So that's how you do like unit test and integration test. And when we writing test, it is really good to make, really a good application and bug free, so you'll have a confidence in your code base. And yeah, for we have, when we write a react component, we have different type of state management things, like we can use the context, and or we can use the redux thing, right? So for that also we'll have to like mock the things and render our components by wrapping with the provider, and also that our component takes everything, and it will have the value. So I have written one more test for that. So yeah, so here I have a component which is a counter, and in this counter, right, so I have created a context here, and then also I am taking the initial state and the function, and then just wrapping this counter component which has the up button or down button, and which is actually rendering the value to the DOM. And here I am passing everything. So then okay, so here, like when I'm performing the action, right, it is happening because of the React context. So for this, right, we can't just render the component and it will work. We'll have to wrap it and make it work. So this is the test here which I have written, render with context. So what I have done is like I'm taking the render function which is given by the testing library, and there I am wrapping my this component like counter provider I am taking, and I am passing the value of counter context. So it is importing the same context which is there in that this counter context component. So I'm just using the same value of this counter context, and then I'm making use of it. So then again I'm creating a test suite, and since I have written 2 3 test cases here, I am just so using it in the before each callback function. So like whenever we have anything common, right? When we want to run it with for all the tests, we can import it inside our like before each, and it will work before running the every test. This function will run. So when this will run, right? So initially we have the text context at 0. So this will be passed like initially our counter is 0, and then after it should be increased when we click on up button. So let's suppose we click it for the one time, then it should be the one. So okay, this is what the behavior is, so this will work. And also like yeah, and if we click it for the many time, then it will be 2, it will be 3, right? So that's how we test. And for the decrease also we can do the same thing, and it will give the expected output. So that's how we'll be writing the unit test for all the components in our application. And also like we have something called a test coverage in just or React testing library and any of the unit tests. So what happened is like mostly, right, to make a good application, we should write test where it should cover more of our code base. So yeah, so you can see, right, this is the snapshot I have taken after writing my test. And here you can see like for some of the tests which I have written have the 100% of coverage, and some has like less than that. And overall it is like 77 and 84 and 78 it is showing. So generally in companies what happen is like, right, they will have the criteria of either like 80%, and generally in my company it is 100% recommended. So we write the test uh, like application where we try to accomplish 100% of code coverage. So that thing also we can do. So we'll be able to know all the features we have written is working fine. So that's what it was about unit and integration testing, and we are testing all the asynchronous thing. And lastly, like we have E2E test. So in E2E test, right, what happens is like since we are testing end to end, mostly we'll be using like different tools, like we have Cypress, Test Cafe, or Selenium, and sometimes it is written by QA also. But in some companies developers also write the test. So that I have not covered since it is a long thing and it will take more of time. But yeah, I wanted to talk about mostly the developer testing thing. So yeah, that's it about. And That's it. So here I have written some link where you can learn more about it, and some blog I have referred, and some YouTube lecture which you can check. So yeah, that's it. Thank you all.
Thank you, Kumar Prince. How many of you learned something new today in the first presentation? Can I see show of hands? That's amazing. And any questions from anyone? All right.
Since this was an example, you hard coded two, right? Because you were giving two inputs to be added. But I imagine, like in a production or in a real world scenario, you will be calculating how many items are being added and then dynamically putting them in a variable to check if those many items have been added. Right?
So generally, what happens is like we write mock or some first of all, like when the build run, right? Whenever we create the PR and all, and our test whatever we have written, it will check, right? So how much test is covered, then only it will pass or fail. So some mocking which we are doing, right? So what will happen is like we just take a constant file and we just make the use of it, right? So dynamically, like what happened, like whatever code you have written, props and all, right, you'll have to actually give it like whatever value you want. It's not like it will take from the real API and it is going to check.
Okay. So what I meant is like if suppose you have an application that is dynamically generating like how many items are to be added,
Yeah,
right? In that case, the test will be really meaningful only when you are getting that
yeah,
count
yeah.
dynamically and then checking it.
Yeah, so I got your point. So one slide I showed, right, for the integration testing, where I was adding like user event dot type I was using to add the value dynamically. And when you will do that, right, for 2-3 times, and then after when you will check the count, it will show that like how much you have added. But when I was doing the like unit testing, right, so there I was sending the props, right. So in that I was sending the props. So I'll have to create a mock prop, right, so that it will take, because it is not going to simulate the behavior which is happening from other components. So that's how like we write the test. Yeah.
Right. Thank you. We have. Yeah.
Yes, we have. Yes, yes.
Whatever you asked is a valid scenario. That is for people generally call it as end-to-end or system tests. So that is where they do that.
All right. So that's our first talk of the day. We are moving forward, but before that, I just wanted to before and we skipped the little introduction part as we were running a little behind the schedule. But Kumar Prince, he is also an avid traveler. So, what's your favorite destination or where you're heading next? Anyone?
Like in India, I have covered like a lot of places, and
Yeah.
internationally only one Thailand. So
Okay.
maybe actually I'm planning for Dubai maybe. So
That's great. Yeah. So if anyone you want to know more about, so you can talk tech and travel both. Uh, and at the second conversation, we have very interesting topic. We have Vivek from the browser company. He has been a seasoned engineer, 20 plus year experience. Most of the time building browsers. Right? That's interesting. So that reminded me of something from my from my last role which I had. So I have been a developer turned community professional or developer relations. I've been into for about 6 years, and the last company I was working for, it's a platform to build web and mobile apps. And the one time when I was taking a session, the pitch which we had was build your first application in 7 minutes. And I said, build your own platform, like build your first platform in 7 minutes. So just like so that was a platform to build apps, but here you can build your own platform. So that's, I think, the equivalent of building your own browser. We all are actually building for the browser, but I think this conversation will be something more interesting. We'll have Vivek uh, talking about how the browser handles JS performance considerations and few techniques how to optimize your JS. So please pay attention. And also I wanted to say we have, if this thing allows, yeah. So we have JSLovers underscore Dell as the handle on Twitter. So if any one of you are tweeples, how many of you are active on Twitter? or we call tech Twitter. That's great. Yeah. So please feel free to tag if you share anything. And yeah. So with a huge round of applause, please join me in welcoming Vivek on the stage.
The mic. Thanks. I have this one. Yeah, I think it's fine. Okay. Hey, namaste everyone. So this is Vivek here, and today I'll be talking about the juggling JavaScript. So the thing that I'm talking about is the browser backstage. So what are the things that we do with the browser, and what happens behind the scenes is the main topic, and under which I'll be talking about juggling JavaScript. So a little bit about me. I have been building the browsers for 20 years now, mostly working in C++, Swift, Rust, and a little bit of JavaScript. So I have been a reviewer and a committer on the Chromium project. So I've been contributing to Chromium, and for the last 13 years now. So the dev tools that you use, I have contributed into that one. Previously, I also started my journey with WebKit, which is powering Safari browser. I have built the browsers across a range of devices, ranging from mobile, automotive, desktops, IoT to XR. So currently, I'm building Arc at the browser company. And then previously, I worked at IBM, Nokia, Samsung, and Visteon. So I'm quite active on Twitter, and this is my handle. If anybody has any questions later on, so if you can feel free to reach out. So let's start with what is the JavaScript, right? And of course, I mean, this is a JSLovers meetup, so definitely I would like to skip that part. But while I do that, I would like to give a brief history of JavaScript. So this is little chronological events that you can see here. So it was built at Netscape in 1995. Brendan Eich was the lead developer, or like the inventor of this one. So he wanted to build something for the web. It was called Mocha initially, and later it was renamed as LiveScript. In 1996, when Netscape partnered with Sun Microsystems, so basically Sun Microsystems, you know that they built Java, and then they really wanted to kind of capitalize on that name. And that's the reason the LiveScript got renamed to JavaScript over here. Apart from the name, there are no other similarities into that one. 1997 is when ECMAScript, the standard official JavaScript standard, came out. And then basically this is the standards body behind that. jQuery, I mean, how many of you know jQuery? I mean, use the jQuery, right? I mean, this came in 2006. Afterwards, like I think as the JavaScript was catching up with the world, and then basically the server-side community also really wanted to leverage that, and that's how Node.js happened in 2009, and eventually 2011 is when TypeScript arrived. So this is a little chronological order of the things. So today I'm not going to talk about any of those things, but today I'm going to talk about how is it processed, the JavaScript, how is it handled inside the browser specifically. So under this is the JavaScript journey. I mean, I just kind of summarize it at very high level. So today, when you write the JavaScript, it is basically can be handled by browser or Node or some of the other containers like Deno as well. So what I mean, the JavaScript can be delivered via the cloud, or also can be delivered, and it can be on your system itself. So browser can handle that. But then the main journey here is about the JavaScript engine, like how JavaScript engine handles this part. So I'm not going to go into the very specific details here. I just want to kind of give a high-level overview of what really happens behind the scenes, like when you ship a JavaScript to browser or Node, for that matter, what really happens. So I'm going to be talking about various details of each one of these steps here. So there are, I mean, this is just an overview here. I'm just showing it. As we go into further, I'll be kind of talking on each of these components. And as you see, you can see at the bottom of this one, it's like where is this kind of a live map that you see what component I'm talking about here. So let us start with the first parser. What really is a parser? So you write a JavaScript which is in the textual form, but that needs to be understood by the engine. So for that, it converts the input JavaScript into something called as an AST, abstract syntax tree, and then but JavaScript parsing is predominantly one of the major page blocking bottleneck. So when you build your websites or web apps, basically JavaScript parsing takes considerable amount of time. Few of the studies that I have mentioned over here, they talk about taking 15 to 20% of time on parsing. So this is really kind of a major blocking factor in like what kind of experience that you would like to give. Of course, on that mobile web, even further spends around 3 to 4 seconds parsing the JS. So overall, so today I'll be speaking mostly on the V8, which is kind of popular engine used across like many of the browsers, I mean Chromium derivative browsers, and as well as Node. So engine like V8 implements two of the modes called eager parsing and lazy parsing. I'll be going into the details of each one of these ones. So here let me know if the code size is better. Okay, so eager mode parses the JavaScript as soon as it is loaded. So it is parsed as the incoming JavaScript is parsed and it is made available for execution immediately. It can improve the performance of the web page by reducing the parsing time, but at the same time, it can take more memory. So basically, it's a trade-off that you need to do. What kind of expressions or what kind of JavaScript is actually parsed as an eager parsing by V8 kind of JavaScript engines is the top level expressions. So top level expressions, I have given very like subtle examples here. So if you have declared a const a, which is like 100, initializing it with some value, so which is like a top level expression. So this would be parsed by the JavaScript engine as soon as it sees this one. As soon as the source code, I mean this line arrives, so it basically starts parsing this one. So another thing is iffy, the immediately invoked function expression. So basically these are also immediately accessed, I mean parsed by the V8 engine. Now, like you might wonder, what is lazy parsing then? Like why would we worry about? So lazy mode defers the parsing of the JavaScript until it is needed. So take for example, here I have the function called world, but it is not yet called by anyone. So basically this, when the engine starts like tokenizing this, the input source code here, it sees that this particular function is a function definition, not a function call here. So it basically just defers the parsing and it puts it into a lazy mode of parsing. And like where would you use this one? So the lazy parsing is often used in asynchronous JavaScript or your background tasks. So you would probably use it there. It uses like I mean, comparatively, it's kind of the memory usage that the browser is required. It is little lesser, but it may cause garbage collection pauses over there. So this is like a trade-off that you would need to do. This is really important because when we use the bundlers, so it kind of tends to add a lot of these top-level expressions, and it might block your page load performance. So next to this one, as you are seeing in the bottom of this, the map, so you can see that the next part after the parsing comes into the abstract syntax tree. So what really happens in this one, I will be going to an AST Explorer, which is basically a tool to show you what really happens for this particular code over here. So let me know if the font size is okay. Yeah. So I have taken the same example here where we have declared three like expressions at the top, and we are just doing a console.log with the like last expression. But my main focus here is not on what is this JavaScript code, but I would like to show you what really happens inside the AST, like how AST is built. So you can see that when you hover on const a, it basically starts showing you this tree on the right-hand side. So you can see a little bit of high-level explanation. So this is a variable declaration. When you hover on the right-hand side, you can see it highlights what line it is kind of corresponding to. So this is like, it consists of various declarations. You can use multiple declarations into this one. So it identifies that this is like one such declaration called as a variable declarator, and its name is identifier is a, and it has been initialized with the value 100 here. So you can see that this entire thing that you can see, I'm not going to go into the very specific details, but this part I'll just show you on the C over here. So you can see that C is declared, and it's a binary expression. So because now C is initialized with A plus B, so you will see a binary expression, and on the left hand side is basically A, and the operator is plus. On the right hand side we have B. So just the way you would kind of imagine a tree would get built. So you can visualize that inside this one. So this is what an abstract syntax tree looks like. But what happens behind after this one? Because like this, as I was talking about, it has a chain of actions that are performed on this thing. So after this, you have basically a bytecode that's gets generated by traversing this AST. And before we get into that one, I just want to kind of show a few of the things here. Like if you're on Mac, you can actually install V8, basically the engine. But then you get a D8. Once you install a V8, you get a D8. It's called as a developer shell. So in that, this is my example code here, bytecode.js. And then you can just call D8 -- print bytecode and then bytecode.js. If you are using Node, you can already use this one using print bytecode even on Node. But be aware that with Node, because it has a lot of initialization boilerplate, you would get like many lines of code, and then probably what you are really looking might get lost. So I would recommend use the D8. So here is where you can see. I mean, it's little. I think this is. You can see this, right? So the same JavaScript that we have been seeing from the beginning. What really happens inside the bytecode? How the bytecode is created? So I have highlighted when you are actually doing the C equal to A plus B. So basically, you will see that there is a bytecode add which is generated, and it uses some of this register naming convention. So we really don't have to get into that one. But just if you are interested, I'm happy to kind of take any questions later on. So this is how your bytecode would look like inside the JS engine, and this is what is taken by the interpreter, and then this runs this code here. So you can see that the bytecode is fed into the interpreter, and interpreter just executes this one. Now you might have heard about JIT, just-in-time compilation, and you might be worrying about like what it is. So I mean, most likely everybody would have heard that JavaScript is an interpreted language, but it is not. I mean, it was earlier, but eventually what has happened, because everybody started building the web apps, and then like the performance was really a requirement over there. So the browser engineers as well as the implementers, we really also wanted to kind of take the leverage, leverage that. And what we wanted to do is, can we take the AST and convert it into machine code? So basically, this is what really happens. I'm going to show you this as well. So I have all these references. So yeah. Again, don't worry about if you don't understand any of these things. This is just to kind of give a high-level detail about this. So this is, again, the same piece of code here, A plus B. You can use a different compilers over here. We can speak about this later on. But here is where you can see the machine code that is getting generated. So if you are familiar with like assembly language, so this is how the same JavaScript that we wrote, when the compiler optimizes it and the jitting happens. When I say jitting, basically just-in-time compilation. So this is what all the things really happen here inside the engine, and this is the machine code that is executed directly. So as you can see, the code is taken from the AST and then basically from the bytecode, and from there it is converted into a machine code over there. So yeah, coming back to the performance part of it. So as you can see that there is a bytecode, the performance is really good, but then like with the machine code, the performance is even like it kind of exponentially increases. But should you use everything in a machine code, or should you use everything in the bytecode? That is something that the engines basically take some conscious decisions on that part, because it really depends on the engine, how it has implemented many of the things. So as a let's say JavaScript developer, you might not have a control over like how this is actually handled. But then at the same time, it's good to know like what really things would happen. So one thing that I can give an example is, let's say, dead code elimination. So you have written an if block and else block, and because the AST would be generated for if and else as well. But as the compiler, I mean, the interpreter starts seeing that you are only hitting the if block, the some condition has turned it to be like it will go always into the if block. So it removes the else block and just makes the if block as an AST. I mean, like it jits that part, and then basically a machine code is generated for that part. So I have few examples that I would like to show later on this part. So now coming back to the browser render pipeline, right? I mean, like so far it's all we talked about what really happens inside the JavaScript engine, but the browser is an interesting piece because when you are building a browser and basically running an app inside that, you need to take into account a lot many things, not just the engine part. Engine is just one smaller piece into this one. So the wireframe here that I have shown is kind of a pseudo example of a YouTube. So you can see that a YouTube page loads up, and then basically you have comments, and then on the side you have the recommendations here. So what really happens inside the browser render pipeline, right? So I'll be staying on this slide for a while just to kind of explain what this slide is and what are these, like how do you read this or how do you interpret this? So for this, what you really need to understand is consider the browser pipeline as like a train track where each block is representing the time that it gets. So when we say 60 FPS, I mean, you would have heard about like my app needs to be 60 FPS, or the current display that I have has a ProMotion display, which is like 120 Hertz. So now what it really brings in is, as you can see that this timeline over here, so you can see that the page load has started. You can see that the YouTube, the first thing has come up, but nothing has actually rendered. It's basically started like laying out and doing some sort of calculations. And as this timeline progresses, you can see that at the final last of this one, you will see the YouTube has been fully rendered over here. But in the in between stages, you can see that there are few blocks which are still getting loaded. There are few blocks still getting rendered. So all of this stuff happens. And then when we say that my app is a 60 Hertz or 60 FPS compliant, that means your app is capable of generating each frame, like any change that happens in your code at 16.66 milliseconds if you're running on a 60 FPS display. And then within this block, within the 16 milliseconds budget, what you really need to take into account is the browser would be fetching the network resources, your Ajax, or like whatever the request that you will pull, all of that thing will go to the fetch or Ajax. The JavaScript will be loaded. Again, it will be parsed execution. There is a garbage collection. I'm not going to be talking today on the garbage collection, but this is what really happens. But apart from that, there is a layout, the CSS style computations, input, because when you do the mouse moves, everything basically it goes through this one, and the final, the paint stage. So paint is basically when everything is actually rendered onto the screen. So that's the basically final stage. This loop continues on every of these blocks here, every block here. And as you can see, there is a time, there is a deadline timer that the browser gives to the JavaScript saying like, hey, I'm running at 60 Hertz, I'm running out on a 60 Hertz display. You need to give me a frame in 16 milliseconds. I mean, if I just round it up. So this is the kind of continuous activity that happens. And then you can see that when it goes to 120 Hertz, basically your time shrinks to 8 milliseconds, like half of it. So that's the reason your web app performance and the responsiveness of this thing really depends on how you would understand this particular like render pipeline. So today, mostly I'll be kind of giving a small demo on this one. Just a moment. So I wrote a simple, not really fancy stuff, because I just wanted to kind of show you what really happens and how you should really care about this one. So I have written a simple clock. It shows like in the millisecond granularity so that it runs really fast. I'm just going to show you a few of the things here without actually going into the dev tools. So basically, when you start, you can see that it is kind of really fast updating the timer over there. Now, the main intention of this thing is to show you what really happens behind the scenes. And here, this example uses something called as a request animation frame. How many of you are familiar with request animation frame? Yeah. So, and then just to kind of give a comparative performance thing, I will be using the set timeout, which is kind of a go-to buddy for us, like as a JavaScript developer. Nothing is happening, use set timeout. So the performance impact of the set timeout, you can really see that. So the demo I would show is basically I would start the demo and then you will see the request animation frame is ticked here. That means my example here uses the JavaScript, the request animation frame. The moment I hit to some point, I'm going to uncheck that, and then we are going to use the same thing with the set timeout. So while I do that, I would use the DevTools. Basically, this is, I'm using Arc, but then you can use it on any Chrome-based or Chromium derivative browser. This would work. So you need to go to the Performance tab here in the DevTools. I'm going to zoom this thing in. Yeah, so you can use, you can start the recording. Let me just reload the page. You can start the performance recording over here, and then after this you can hit the start. So as you can see that basically the timer has started. We are using the request animation frame. Just at, let's say 52, I'm removing that one. I'm going with like set timeout based implementation over here. So let it run for a while, and I'm just going to stop this and let it process. So yeah, I'm just going to move this to a separate window over here. I need to be a little, yeah. Yeah. I will zoom into this one. So don't worry about this if you don't really get it. But then what do you see here on this timeline? What do you see? I mean, any guesses? Yes, so basically not the page, but like we are kind of running in a loop, and then we want the browser to run and like paint it, right? I mean, you're changing the value and the browser takes care of showing this up. But then if you see if you notice this one, so the first block here, I'm just going to zoom this thing a little bit. So you will see the first blocks are like, you will see a lot of green, I mean, like a lot of greenery over there, right? And on the other hand side, you will see a lot of like yellow markers over there. So these yellow markers are nothing but your JavaScript is getting executed like that many times over there. Okay, so how is this all related to your FPS, or how is it all related to your frame rate that we just came out, right? So I'm just going to zoom into each one of the block over here just to kind of show you. So if you go on the top here, you can see the time is changing here. Okay, so this is like every frame that browser is actually, you are asking it to paint it. Basically, it is coming over here, and you can literally see, you can just scroll over this timeline, and then you can see that. So you can see that it's 550, 581. So why we are showing this number, this demo is really important, because now when you have generated a frame, and what would be the timestamp? So ideally, if I have a 16 millisecond budget, I mean, on this device, it is 8 milliseconds budget. So you would basically see that showing up here. I mean, like as each and every individual frame. But that's not really only the interesting part that I want to show you here. So the other part that I would like to show you is I will start zooming into each one of these blocks, like how each frame was generated here. Okay. So I will go to the last level granularity here. Of course, I'm running because I'm connected to an external display. It is running at a 16 milliseconds budget. So you would see that on my, this is like a tiny chunk that the browser is showing you, that this is the 16 milliseconds budget. Like, how are you doing in this block? So here is where, if I even start going further, you can see that this is 315 and this is 332, which is basically approximately around 16, right? I mean, between them. But most importantly, what you really need to look at is this block. So now I'm going like very deep into this one. So you will see that all the things that I talked about. So this is a task, because now I'm using a request animation frame. So the browser has given me a tick saying like, okay, you have to basically get me this. And this is where you will see the task is run. The time that it took is only 42 milliseconds, sorry, 0.26 milliseconds. Okay, because I mean, I have written a very simple JavaScript which will just take a clock and just blip it there. But the other important thing that you will see that the animation frame fired, this will be fired by every browser, like irrespective of Chrome or this one, this will be fired by even Safari. So the request animation frame is available on all the browsers now. So once you see this, because I have written my code, I'll just show you a little glimpse of the code. It's not really super clean. Just want to kind of whip it up. So the JavaScript code is something like this. It has an update clock function. It has an init clock and stop clock. I mean, high level. But then when you see the update clock, I will not go into the specifics of like how I'm getting it, but this is where you can see. So I'm calling myself under request animation frame. So this is like one more function that you get it. If I'm not using that request animation frame, I'm using the set timeout. Like I'm just kind of queuing it into the JavaScript queue. So because of this, you can see that when I click on this function and when I see the call tree, so you will see that sorry about the font size here. But yeah, here is where you can see my request animation frame and my function is actually getting executed here. So, and then it is also showing you how much time is taken by the browser on each one of the operations here. And pay the close attention that all the operations that we talked about, right? I mean, executing a JavaScript, doing the layout, because we are changing the input, right? So then there is a pre-paint, paint, and commit. Basically, commit is the phase when your web app is telling like, okay, I'm ready. Now you take the frame and then like render it onto the screen. So this is interesting, isn't it? So now, as you can see, that for a 16 millisecond budget, you will see only one like a flame chart over here. Let us see what really happens on the other side. As you can see that this is like a pattern that continues here, right? Now let us go into this segment and do the same part here. Take 116 millisecond block here. You will see how many times your JavaScript has run. So your JavaScript, these many like buildings like here, that many times your JavaScript has run over here. So as you can see that there are 1, 2, 3, 4, almost 4 times your JavaScript has run. But what is it? What's the use of this one? Because your GPU is going to just take one frame out of this one, but you are kind of overproducing it. But the GPU is just going to take the whichever it kind of like it kind of takes at the last. So we are kind of doing an extra processing, which would cause the performance thing, like you are kind of over processing in each block. And then what happens is your battery, I mean, if you're running out on this one, so battery would drain. And if these apps, because we did one study, according to that one, 80% of the time that all of our users, they spend into the browsers. And let's say if they are using your web app as like a daily driver, you would probably face this issue. Like people will start complaining, hey, your app is kind of performing really badly, my battery drains a lot. So these are the kind of things that you will see in this request animation frame. So I have another demo that I would like to show over here. So, I mean, how many of you use console.log for in your production code? Like, just a right. So I'm just going to show you one very interesting demo in this one. The same thing runs because this time I'm not going to change the request animation frame. Assume that that's the same one. What we are going to do right now is there's an expensive task over here. So I'll just show you what is this expensive task in the code. So it does nothing. I mean, it has like a 100K loop over here. It does some random calculations. I mean, I just wanted to kind of make it more compute intensive. But then, like, if I have logger checked, I just log this value onto the console.log over here. So now we will go back to the tools again, and let me just put it into the side-by-side mode. Go to the performance. Start recording this. I have started this same thing as previously, and I'm going to click on the expensive task. what I really want you to pay attention is like what really happens to this clock. So I clicked that one, nothing really happened, right? And like, let me click on multiple times, nothing really happened. The moment I have log, you will see it stopped. It stopped, basically like your rendering has stopped. So how do you see this? How do you see this into the performance thing? You will see that here in the performance traces. Okay, it's, I mean, I took a little longer. Should have been a little conscious about that part. Yeah, but then let me go into the detached mode again. Here is where you can see. So I was clicking on this multiple times here. So this is where my JavaScript execution is happening. I don't know whether like hills over there, because this doesn't zoom, unfortunately. Let me try it. No. So this is where basically my execution is happening when I'm not doing a console.log. But what really happens here? What is this interesting piece over here? So this is what you can see. Like I have this function, like what is really happening. So do the expensive work. So how much time it took? So basically when you look at the call tree, so you can see how much time it took. So do expensive time, it took 3 milliseconds. So I have budget of 16 milliseconds. So this is still doing fine. I mean, I have still 13 milliseconds left for me. But what really happens when I started doing the console.log over here? So let us go to this piece here. There's a glitch, right? Here you saw, I mean, you saw a glitch that my paint really stopped here. You can see that my paint is not really happening. So it kind of continued here, like 577 continued for quite a long time. And afterwards, basically, it kind of resumed it. What was really happening at that time? So when I go into this part, so this is what you can see, that I have an execution of my expensive task. Now, at this point of time, it is taking me 946 milliseconds. So that means for 1 second, one whole second, you had blocked the browser's main thread. So in this, what was really happening? Because your main thread was not able to generate a frame, and the GPU was looking for one. So as your web app did not produce one, it took the one from the previous one itself, and then basically it just showed you that. That's the reason the page was not updating, and you saw that the clock timer has stopped over there. So this is all because I just added a console.log. Of course, I mean, this is a superficial example, I mean, official example where I kind of run this 100K times. I wouldn't do that. I would need to kind of batch it up. But when I kind of see something like this, you would probably understand like how much really important it is for us to be cognizant of the main thread. And you should be basically moving as much as possible off the main thread if you can. So you can use the worker threads, you can use service workers or like web workers. So those are the other venues that are available. Of course, there are certain restrictions that web workers will not have access to your DOM. You need to do the message passing between them. But yeah, overall, this is the kind of thing that goes into the browser. Of course, I mean, I just kind of highlighted the same stuff that we talked about in case we see this. But as I was saying, for this is a request animation frame. So you will see only one here. And this, and what I really also wanted to show you is like the grouping of all the tasks, combined tasks together, like JavaScript execution, paint, layout, and like, of course, finally the paint. But take a look at this request, set timeout implementation. So because it's a set timeout, you will see that there are multiple such calls here. And then here is where you can see the JavaScript execution happened in the separate batch, and the painting happens in a separate batch. So basically, there is no synchronization that happens. So that's the reason it is little not, yeah, yeah. And this is the other example that I showed about the glitch. So yeah, this is all that I wanted to talk about today. Like, of course, there are many things that I did not cover into this one for the interest of this one. But there are like many interesting facts about the memory management, how the garbage collection happens. These are really important ones when we are building the web apps. WebAssembly, I think this is one of the poster boys of everybody now on the web apps. Figma made that quite popular. Then apart from that, there are a lot of the V8 internals that I would be happy to share. So these are the few of the references that are really would give you a good sense of what really happening. The first talk, probably I think many of you would have already seen that. What the heck is the event loop anyway? So this is something that you should see if you have not, because it shows you like what is an event loop and how browser actually takes care of that. It's an 8-year-old video. It's quite long, but all the principles are still applied. There are a few things I just wanted to kind of show you around. When I mean, you can do this performance analysis later on, but I have this CSS, pure CSS animation here, which kind of runs without any JavaScript. Okay, and then, I mean, it looks gorgeous on a 120 hertz display because it kind of smoothly goes around. But this is purely based on CSS. It doesn't use any of the JavaScript over here. So you can use this example to see the performance analysis of this one to understand what browser might be doing at this point. So apart from that, the AST Explorer that I showed, the compiler explorer is quite another interesting one. And all of the things that I showed you in the performance panel on the DevTools is captured in the DevTools docs on Chrome. So this is the last link. So any questions? If not now, I am happy to take any of the questions later on Twitter as well. So
Questions, anyone?
Hi. So my question is related to browser only. So while building application, have you faced any cross-browser functionality challenges? Because I actually did. That's why I'm asking you. Like not in my day-to-day job, but while I was practicing, I faced one challenge in the Brave browser. I tried to fetch something, but it didn't come. It happens not to me only, but some other friends only.
right,
Then we switch to Chrome and then it works.
absolutely.
So how to build application which can works in multiple browser? Because we are developers, we can switch browsers because we are developing stuff, right? But the end user will not do so.
Right.
So how to handle this thing?
That's a great question. So
Oh.
if you really see, the browsers has a feature detection. So let's say if you have like you right now there is a new spec that is coming up called document picture in picture. You should go and check that, all of you. That's quite interesting one, but it's only available on Chrome right now. Okay, so what I mean, then the API that is available is window.document picture in picture. Okay, that's basically a feature detection that you should do. Unfortunately, that's the kind of a reality that we are living in. Even after like 20 or 25 years of the browsers, we still need to do a feature detection if at all we want to deliver our JavaScript and like make it work across like different browsers. But the browser vendors like us, who are also kind of cognizant of this effort, and since last year there is a web compatibility group for the web roadmap that is happening. So what basically they have, I'm just going to quickly show you that. That's a quite interesting one, and all the browser vendors are actually coming under one umbrella over there. And then they have a compatibility test suite that runs on multiple browsers, and each browser vendor basically exhibits what's the score that they have obtained on various different features that you're talking about. So let's say the document picture in picture, today it is only available in Chrome because it's an experimental feature. Chrome wants to experiment it, and then they're one of the biggest customer for them is their workspaces team within Google. Basically, your Google Meet, Google Docs, all of that one. So they wanted to really push that forward. So if you see Google Meet today on Chrome, when you kind of use a picture in picture, it kind of shows you a nice little UI there because it can take the entire page to show you there, not just the video element. So what that has caused is because of this one, Chrome has a process called as an experimental staging. So when you want to kind of develop a new API, so you would want to kind of push that forward so that the web developers like us can be an early adopter of those APIs and can build apps using that one. So the caveat there is these APIs are experimental. They are going to live for only a short duration, like around 3 to 6 months is the typical timeline. But then it gives you a sense like what kind of API that you can expect. But at the same time, you should also see what is the roadmap for this one. So what is the web roadmap for this particular feature? If you are not using a feature which is kind of a roadmap for the cross-browser things, you are again kind of inviting a trouble. But then you should use the feature detection. I mean, the long story short is basically you should use the feature detection.
Got it. Thank you. So like, can we integrate with a code base in a code base? Like that picture-to-picture mode, what you have mentioned, right? That API stuff or whatever it is.
Uh-huh.
So can we integrate in our code base?
Yes. So that's where basically, if you see, Firefox created like you might be using local storage, session storage, or like IndexedDB, all of that one. Back in the day, around like 7 or 8 years ago, not every browser was also compliant of like implementing that like low-level features like get set items on the local storage. So Firefox created a high-level, I think it's called as a focal storage. I will get that name. I mean, I might be wrong with that name, but they created a library which is kind of a cross-platform. So what you said, basically, they implemented it and then they encouraged the web developers to use that library. So, I mean, you're right. You need to create those kind of an abstraction so that your app developers who are kind of relying on that one, they really need not worry about these like browser specific details there.
Thank
Right.
you.
Yeah. We have one more question from here.
So if you see, the scripting language for the web is for foreseeable future, it is going to be JavaScript itself. And the current, this one new the thing that is coming up is the WebAssembly, where you could write your web apps in like C++, Rust, even Swift, and then compile it to a WASM, like WASM, and you can deliver that as a kind of a resource to your web app. And that web app, I mean, there are few things that I have not covered here, like how to use WebAssembly, because that itself is a big topic. But coming to your question, are there any other languages that V8 supports? V8, no. V8 only supports JavaScript, not even TypeScript. So because TypeScript compiler takes care of converting your TypeScript into JavaScript, and browsers would only understand JavaScript.
Right. So huge round of applause for Vivek.
Thanks, everyone.
So Vivek, as the ritual goes, we would love to know the non-JavaScript or non-browser side of you as well. So what is one thing which you love to do apart from when you're not building browsers?
I mean, yeah. So I like to hang out in these kind of communities so that it is, I mean, again, I'm a techie even now. So I would really love to do that. But apart from that, I'm like more of a family person. So I kind of go out with two of my kids and my wife. Like I do occasionally go, but when I go, I kind of go on a road trips. I really love the road trips.
Yeah. So thank you. Thank you for sharing
Thanks,
that.
thanks
Yeah.
everyone.
All right, folks. So how's the Josh? How's the Josh? Yeah, let's keep that energy high. So we have something. Let's. In the end, actually, we will be having a fun JavaScript quiz. So please make sure you stay for that, and we will also have a winner for that quiz. How many of you were at the React Nexus conference? Anyone? Okay. So we did have one quiz over there as well. I'm trying to struggle with this. Okay. Yeah. No, not the same question. All right. So we have a 10 minutes break right now. During this break, everyone, please make sure you stay within this area and feel free to connect with others, share your story, and also scan this QR code and save it for later. This is the call for speakers form. So, how many of you have always like you always wanted to take a presentation? You have like you're looking for a stage. Anyone? We have one. All right, we have Darsh. Anyone else? So this is a safe space, everyone. So please feel free to come forward. We will announce the next meetup very soon, and you can be the speaker in that. Other than that, we have few refreshments thanks to Geeky Ant's team. Please feel free to utilize them, but please also be mindful that utilize the trash can, and let's keep the keep the keep the place neat and clean. So yeah, that's it. We'll resume again in 10 minutes. Yeah, see you. So let's see who wins. Okay, how many of you are Team Oppenheimer? Can I see? Show of hands. Team Barbie? Okay, both. All right. Let's see. So Iron Man is, of course, winning over here. Okay, so one small spotlight. Anyone would like to share a fun? It has to be a fun project you have built using JavaScript. Show of hands. Anyone? Yeah, we have one. Very quick. What's your name? And then tell us about your project.
My name is Shrish Deshpande. So basically, when I was in 12th grade, I needed to write my journal. So I made a JavaScript website that generates all the readings for you so that you don't have to do any of the experiments. You could just copy down the readings into your journal without doing them.
That's great. Oh, we have one more. Yeah.
So during before 2 years, I was going through some job searches, and I was constantly tired of sending resume to a lot of HRs individually, and sending a template file as well. So I just created an automated form which will just take in recruiter details, phone number, email details, and it will send in an automated email with CV resume to these recruiter email ID automation.
Thank you. So that's great. And anyone who is into home automation? Anyone who has automated something at your home using JavaScript? So one of the things I remember I did was at the peak, like when we were all working from home, I had to figure out how to. I had no idea that the Amazon plug doesn't work with Google Home, right? Because they are separate ecosystems. So I connected. I wrote a JavaScript like a script which was using the IFTTT, and Amazon plug was talking to that script, which was talking to Google Home, and eventually I was able to use that plug through Google Home. So yeah, that's great. Cyborg, I don't know what that is, but the second best is always Iron Man. And yeah, so we have, I think, almost everyone, 46 of you. Please, everyone, you can join Slido and you can enter your questions there, and you can upvote the questions others have asked if you also have the same question. And yeah, so we have our next speaker joining us on the stage very soon. So we'll have Tapas. He will be talking. So he has been a very experienced JavaScript developer, and he's at React Play, and he's a founder of React Play and content head at Showcase HQ. So please join me in welcoming Tapas on stage. So while he's setting up, how's the Josh, everyone? Let's keep that energy high. And also, I actually wanted to share this before the break. How many of you are hiring for your teams? Anyone? You're hiring? We have one person. Anyone else who is hiring? And how many of you are looking for jobs right now? Okay, that's great. So please feel free to connect with each other during the break. We do not endorse any of the jobs. It is all community, but we would love if any one of you find new jobs and projects out of this community, right? So yeah, over to you, Tapas.
Thank you. Okay, so am I audible? I'm not sure it's really working or not. Okay, fine. Okay, thank you, everyone. I'm going to talk about a concept called React Server Component today. So you guys settle down. And I'm Tapas. Actually, a developer for a lot of years. Right now, doing a lot of freelancing. One of them is as a content head at Showcase. Also have a open source community that I'm very, very fond of and proud of. It's called React Play. And started something of my own called TapasScript, very fancy name that I figured out. So you guys can check it out. So how many of you are React developers? At least for once. Okay, I'm in safe hands. All right, so let's get started. what we'll be talking about that React Server components. We'll be getting into kind of a bit deep on React Server components, but more friendly way. I really don't want to bore you with a lot of jargons, a lot of difficult stuff. Rather, we'll be taking it like more about storytelling and try to figure it out like if we understand correctly about React Server components at the end of it, right? But before that, we know React as a traditional UI library, right? It's a UI library. We all know about it, right? And why we know React as a traditional UI library? We all know that before React or any of its sister came into picture, people used to write big monolithic component, and then React helped us to kind of get into component architecture, break things apart, make things very reusable, right? All these things happen, right? So we are not getting too much deep into that because you're all aware of it, right? So there's no problem with that. We also know about this, right? Once the components are there, components have to talk to each other. If there are two components, if there is a user component and there is some other component, they need to talk to each other. For talking to each other, they have something called props through which, through which the components actually talk to each other. And also each of the component has their own data, right? That they have to deal with, which is private to component. What is that called? State, yes, that's called state. So we all know about the state and props conda. So these two slides were just recap, but it's time to look into the patterns a bit differently. That's what the React Server components will come into picture, and that's what we're going to dive into. All right, so today React doesn't have any problem, to be very honest. But again, of course, if there is something, there will be always critic. And there will be something like, people will be trying to figure out there is some fault of it, and which is good, because if that fault is found, the ecosystem will improve, right? All of you agree, right? Otherwise, there won't be any manager sitting in front of us and evaluate us in office, right? Or one-on-one won't happen, right? So it's good that things get evaluated, and that's why the inter-community come into picture and they try to improve the stuff. But I told that we have to change, or we have to look into this pattern differently because of three reasons. One reason is of user experience, because we care for it. We are building everything for our users unless it is only me using, but I am also a user in that case, right? So we are building things for the user. So if we care for user experience, we care for things that maintainability, a big part, right? Somebody has written a project. I saw somebody shared on Twitter, right? I think it was, I don't know who was like you should write a code in a way like how you're writing a love letter to your girlfriend or boyfriend, right? So So yeah, it's true, right? You should write something like which needs to be far-reach maintainable stuff. So maintainability definitely a thing, and of course cost, right? It's a big factor. So I'm actually trying out something very recently. I love the word called entrepreneur, if I'm pronouncing it correctly. So leaving everything, I'm trying to do something on that line, and I know like what cost means, right? I started realizing what exactly cost means. So cost is a big thing. All right. So as we really bother about these things, and as there is a paradigm shift that is coming in the form of React Server components, I am hyping it a lot so that you guys like it. So we are going to talk through, or we're going to go through each of these pillars, like user experience, maintenance, maintainability, cost, to see like what is React today without React Server component, and how server component to solve it to some extent or to great extent. Okay, the promise for solving it to great extent. Okay, so let's talk about user experience. Last bench can see the code? Okay. So the code is kind of very simple. There is a wrapper component called course wrapper. Inside this, there is something called course list. And inside that, there is something called testimonials. So course wrapper is a parent component. Inside that, there are two siblings. One is course list, another is testimonials. We have written this kind of code again and again. Now, imagine that both course list and testimonials have their own API calls. Okay? So course list goes to connect to the database, make a request, get a response, render the stuff. Testimonials also does the same thing. They have their different APIs. They're connected to the different table, okay, structure in the database. So they deal the time, the latency that they might get to retrieve the data from the server will be entirely different. So in some cases, I'm not sure if you have seen, but I've seen in some cases I try to mimic this in PPT, a bad one, but try to digest this one. So to think about it, it's like a course wrapper. And then what happened if in case testimonials data comes fast, testimonial appears, still course list is somewhere. How do we do this? How do we manage this? We kind of do things like shimmer, give some kind of loading indicator over there, tell that users, please don't run away, things are coming, wait, and then once happened, things comes, push the testimonial down, and it gets adjusted somewhere. Okay, with this kind of bad PPT animations, you would have understood like what exactly happened, right? So this is one definitely user experience problem, right? That we give it to user. And then depending on the latency, depending on the time that it takes for this request response things to happen, the user experience can be that good or that bad. That's number one. Let's take another example. Kind of similar kind of code, okay, but little bit of difference. Again, I have a course wrapper. Inside that, I have a course list and a testimonial. But now I thought, okay, why not? Again, we have written this code. We have written this kind of code a lot of time. Instead of like course list and course testimonial making the individual call, let's course wrapper also make some calls. So in this case, course wrapper, what it does basically, it fetches some kind of wrapper input. If you're able to read it at the last bench, and then it does something with the info. Similarly, if you have the next one, the course list, again, fetch the list and do its rendering. Again, testimonial does the same thing. So basically, in this case, each of this component, what they're doing basically, they are going to the database, they're making the call, and they're rendering the data that they're actually fetching. This is another case. The first case we saw, wrapper is not making any call, only the children are making call. We saw like what kind of problem can happen. Now wrapper also making call along with the children. What kind of problem can happen? And can anybody answer? So child has to wait till parent rendering kind of takes place, right? So if the parent is taking a lot of time to kind of fetch the data, child will just keep sitting there until the parent finishes. So again, another user experience problem. All right. So we have actually told like that. Okay. Now in this case, there is one more problem. Let's say that I decided people are writing a lot of bad testimonials about the courses. I want to remove testimonials altogether. I want to get rid of testimonials component altogether. So I go ahead to the UI and remove testimonial component. What I would have forgotten is to kind of remove it from the database, remove it from all the calls, all other layers. So that is like stale piece sitting somewhere. But UI piece I have kind of cleaned up. Tomorrow a new DBA comes or an API engineer comes, they will ask, hey, what is about testimonial? Did you guys have ever had a testimonial? Are you planning to build it? Then it will kind of knock my head and I'll do something about it, right? So there's a chance that you will keep something still because you're actually detached from the other layer and then removing something from one layer. So this could be another problem that you can face. Okay, so you answered correctly, right? The parent one has to finish for the child to kind of come alive. What is this problem called? Anybody knows? A request goes and yes. This is what it is, a beautiful waterfall, right? So that's the problem of waterfall. We know that the nature of waterfall, the request response waterfall. So this waterfall is bad for user experience, we know. After talking about two user experience example, I'm moving to maintainability. Let's talk about maintainability and see like how you recognize this problem. I have given a hint already. So this is, again, now I become little more smart. I don't want wrapper to kind of make all the call. I don't want childs to make all the call. I've written one service in the backend, made one API, made the call, fetch all the returns, pass them as props to all my components. My problem solved. What problem I can face here? So yes, so one thing is like every component has to wait for all the data. Again, the same problem of if I'm just removing one, if I'm just removing testimonials as a feature, but testimonials data is still in the page all details, I have to go and selectively remove the things, right? Both the problems are there. Okay, people are smart here already. I don't have to tell. So if I remove testimonials, same problem. I have to do something with these fetch details. Okay, so the problem of maintainability, right? That comes into picture. Cost. How many of you seen this? I love JavaScript. Everyone does, right? Nothing to blame. I mean, see, there is a JavaScript versus PHP war always happens on Twitter. I don't indulge myself on those because I love JavaScript. But this is a fact, right? And not only your node modules to be blamed, to be honest. Node modules is there. But how about the components that you're writing? There are tons of components. Everything gets downloaded on the browser, right? Everything gets downloaded on the browser. Then only things gets interactive. Then only things gets live in front of your user. Then only they can actually use it. What does it incur to? It incurs finally the cost. You was talking about like, sometimes the mobile battery goes off. There are so many resources to handle things like that. Ultimately, everything is a cost. The cost of everything come together to result into a bad user experience, right? So for good, we spoke about 3 problems. React is not bad, React is good, but we have to accept that there are some problems and there is a solution to it, okay? Now, before I go to the React server component, the term server with a client-side UI technology sounds very odd, correct? So we have to understand a little bit of client-server thing. In this room, I'm sure all of you understand, but still a recap, right? So client-server thing, we know these are clients, basically our browser, be it on kind of some mobile devices or our laptop, these are like client. Somewhere far where our data resides is our server. Could be in the cloud or in a physical server or in CDN somewhere else, right? So you know about it. And when client needs the data, it basically requires the data and then it gets the response. Very simple client server model, but of course things are much more complex and much more painful than that. Similarly, you can get it from any other pieces as well. So we know about client server thing. So with this client server knowledge, let us go back and understand what client components mean in React. So before I talk about client components, anybody want to take a stab like what exactly client component means in React? Anyone? Okay, so I'll help you. What exactly client component? Basically, in context of React server components or in context of React 18, every component that you are downloading on your browser is client component. Okay, so one very simple definition. Anything that you are downloading on your browsers for your customer browsers is a client component. Now, if you go to your browser, go to the F12 inspect mode, then go to the script stack, you should be able to see very clearly. I'll show you. You'll be able to see very clearly. Somebody didn't like it. So, so you will clearly see like what are the components you are actually downloading on the browser, right? So we'll see that. But let's understand what is client component for a moment with some animations that I have tried. And again, the same example: course wrapper, course list, testimonial. Course wrapper being the parent component, and we have 2 child component over there. I have a client, and as I have a parent and child component, think about the bigger one is a parent and the smaller one is a child. You have 2 components over there. And these 2 components, what they're doing is basically they want to fetch some data from the server. Okay, so I need server. So I have some server somewhere. Okay. Now what this will do, first this guy will request something. Now we don't know like how long this request is going to take. It might have some latency and then the response comes back. Once the response comes back, I get the component alive. This is how things work, right? You know all, right? The second one then goes back and then comes back, then component gets alive. We know this. So it's a pure waterfall. That's what we're talking about in terms of client component. And both the components are available on client. It means that if you go to browser, you should be able to see these components on your browser. So far good on the client components. Now what we're going to do, we are going to see like, if you see, we all actually got the answer, like from the course wrapper to course list, there is definitely a waterfall exists. And wherever this waterfall exists, it means that there is a chance of high latency. And if the latency is high, your customer experience is going to be bad. Okay, so this is what we all accepted. Now let's get into server component. Okay, so what exactly server component means? Now we showed like, we had these 2 components and we also had server. What if, just imagine, this goes to server. Both the components goes and reside in server. Okay. If you have not explored server component yet, just imagine that if this can happen, how good it will be. So what are the repercussions? What are the implications? Or what are the advantages that it can provide or it can bring? Okay, so let's try to understand that. Now client makes a request. It means that your component makes a request. But you see what one thing happened, your component is no more with client. Your component is now co-located to server. So it means what exactly reduced by default is the latency. The latency that you had from your client to server is automatically reduced because now the component is actually resided into server. It is very close to your databases, very close to your data store and all these cases. Now, whenever there is a request, what is this guy going to do? Your parent component just going to fetch the thing, very low latency. It's not quite going to call through the where and all these things. Your child component also going to get, and it's going to give you the result immediately. So far good with the conceptually of the React Server component. I'll just again explain. Only thing that we did from here is like instead of keeping our components on the client side and making them go over the where, fetch the data, we just move them simply to the server side so that the latency is reduced. They can actually fetch the data from the co-located database, data store, or whatever it is. And then once these components are ready with the data, server sends those output back to your client so that it can be rendered. Exactly that is the thing happened over here. So far good, right? Now, with the server component, how many of you know this diagram, React developers? What is this? Okay. So this is like, if you call this virtual DOM, and let's call each of this node as your component. Let's imagine each of this node as your component. And I've given some legend over here, like it's like client component, all blue or client component. So it means that today, till React Server component we have used, let's assume that we just know React Server component theoretically, we don't know it practically yet. Till React Server component came into picture, we have seen this tree like this. All these things are client component, and they actually form the tree. They have a root node. From there, if you have to pass some data to the lift, how do you do? Either you pass the props, or you have context API, or you go much more bold to use Redux or things like that, so that everybody kind of share data. So far, so good. But with React Server component, now what you can do is like, you can actually do a mix and match of your client and server components. Okay? So it means that there are certain components that can be completely baked in the server, sent to you, but there are certain components that can be there in the client. Now you can catch my collar and say like, okay, you told that server component is fascinating, it is doing all the good job, then why do I need client component at all? What is the reason? The reason is very simple. The component at the server doesn't know anything about things that happen on the browser. We had a sort of session, from Vivek on the browser. Browser gives you all the interactivity. So if you have to click on something, what do you rely on? A click handler. Who gives you a click handler? It's every browser that they implemented the click handler, the mouse movement. So all this interactivity, right? So if you need interactivity in your component has to be a client-side component. If you don't need any interactivity on the component, it has to be a server-side component. Let's be very clear. So once somebody asks, can I use server component for all? My answer is yes, only if your app do not need interactivity. Okay? Or a portion of the app doesn't need interactivity. Now, this statement is really not negative. If you think very well, just close your eyes and imagine a web page. How many buttons you can imagine on a web page, on an average? Give me a number. 2, 3. If you tell 10, I'll want to look for the designer. Right? So it means that in a web page, you have the interactivity point of 2. Along with that, maybe a search bar where people will type, maybe a pagination to click somewhere to go, things like that in normally. So altogether, maybe like if you want to make it really crowded web page, it will be like 4 or 5 interactivity point will be there. But if you can handle this interactivity point alone in the client side component, rest everything you can do in the server side component to gain the speed, to gain the maintainability, all these factors that we just now spoke, right? So you can use it only when you do not need interactivity. You can use server component only when you don't want to deal with any kind of state, so-called React state and effect. You guys know about React state and effect, right? You know everything, right? How do you manage React state and effect? You manage with use state, use React state, and then with use effect, you manage the effect, right? So if you don't need to manage effect in a component, sure shot, it's the server side. Next one, only if your component doesn't depend on any kind of web APIs, like browser web APIs. Browser has tons of web API. Like you have console, you have local storage, you have things like Bluetooth API, you have a bunch of APIs that interesting APIs that you have. So in case your component doesn't deal with any of this, it's a sure shot candidate again to go for the server side stuff. So this tree is justified. So it means that in your application hierarchy, you can really mix and match client-side component and the server-side component for better results. We are good? Okay, so I know I spoke a lot. So what I'm going to do is like I'm going to show you a small demo. Um, how many of you read through React.dev? I read it almost daily. So they have clearly told, right, if you want to start with a React.js application, start with Next.js. A lot of people got scared like React is going to die or things like that. I have my own justification. It's not the case, basically. So the demo that I prepared with Next.js. But you really don't have to know Next.js here. The only reason I prepared with Next.js is because I want to keep it as forward-looking. Because when React themselves are saying that if you want to start a project, start with Next, I won't reinvent my wheel and go set it up a lot of things, in the messy way. Rather, I'll use Next.js. So I'm not going to teach you Next.js here. Rather, I'm going to teach you like how the server component works and how Next.js adopted the entire server component and making it work. How many of you cook at home, especially the male population here? Yeah, I do also. And when I was actually studying server components, this resonated me. Like my wife, what she does is basically she cooks, she marinates everything, make everything ready, almost all the oil, everything salt, everything will be there. So I do like, if I have to cook something like non-veg, I just cook and I'll just do this. That's what I felt like happened with React server component and client component, right? When you see, so React server component basically does everything, leaves everything, to the client component, do the least amount of interactivity, and let's get the job done, right? So that's one analogy just came in my mind. So I'll just quickly show things. Okay, so this application, okay, I'll just put it here. So, okay, all of you know this. What is this? This is Mongo Compass. So this is the UI to interact with MongoDB. Again, we are not learning full stack here. It's just the server component stuff we'll have. So what is our server here? We have a MongoDB. And the Next.js already has a server side, you all know. It has, all the server side pieces already know. So what I have done is basically I have a very simple API written on top of MongoDB, which retrieve number of courses. We spoke about courses already. Now what we're going to do is like we'll see one Next.js client, one Next.js component, which is like a React component, which is accessing all these courses directly. Okay, without depending on any APIs to be made, without depending on any express code to be written, without depending on anything else to be there, right? It can directly actually access that. So let me see how I can actually show that. I'll increase the size. Is this enough? Okay. Okay, so what exactly happened here over? This is a page which lists down all the courses. It makes a call to the DB, and it gets the courses, and then it lists down on a page. Now, if you think like you are doing the same thing on React, what do? How will you do? Quick answer, you will have a use state. You will manage an array as a courses state. Then next, you will have a use effect. On that, you will do some fetch and things like that. Then we get the thing, populate the state, go to your JSX and do the stuff. Now look at the first line. It says DB connect. The first line, what you are doing, you are actually connecting to MongoDB. Okay, the code that usually you have seen in the server side of the pieces, right? The next line of code, what it says is like, get the models from the DB. So if you are familiar with Mongo, there is a Mongoose stuff is there through which you can actually do the model ORM tool and get the things. And then forget about these things. Look at this. You are actually querying the database here. Find all the courses, select the name, maybe some other parameter and get all the courses. And after you are doing all the courses, what you do, fantastic thing is like you are passing this to your child component. So here, if this is my root component, this is my server component. The root is my server component. Underneath, I may have another server component if that component doesn't need any interactivity. Have you noticed I don't have any button, I don't have any search bar, I don't have anything over here. So there is no client interactivity at all. So it makes sense completely to treat it like a server component. And in case Next says 13.4, everything by default is a server component. If you have to make any component as a client, you have to explicitly tell with a directive called use client at the top of the page that, boss, this is a client component. Otherwise, it's going to treat everything as server component because advantage of server component is huge against client component. All right, so far with me. So this is one simple stuff that we have learned. Now, if I go to add course, this particular thing, with the name, we know like it will have a button for sure to add a course. So if I go over add course, so in this case, yeah, add course over here. So if you see, it has a button, correct? So it has some interactivity. Now if I go at the top, do you see what is defined? So it means that if you want a client component, you will explicitly define that it is a client component. Otherwise, everything is server component. Okay, now the last thing about the demo is not very interesting one though, because I have removed all the styles from this application knowingly, because wherever I show some demo and if the style and all are very good, now people just look into, wow, this app is very good. But here we're talking about server. Let the client be ugly. Okay, so so uh, so you go courses. Okay, it's no style. I've removed everything. Now I'll do F12 over here. It's a simple application. It fetches everything from your database. Once you click on it, it gives you like more details about the course. And then there is a add course button at the top through which it doesn't look like a button, through which you can add multiple courses. Okay, so things like that. Now if I'm going and doing F12 or inspect rather, where is inspect? Yeah, so source. This is the funny part. Do you see app client, node modules, and this? So this is the part I want to highlight. I have many components. The first component itself was page.tsx. Do you see that? Why don't you see that? Because it's a server component. Okay, React didn't bother to bring it in the client side at all. So this is where you definitely save some cost by default. Now think about it. If it is a server component, it is actually using Mongoose to connect to MongoDB. It means that you can use file system to connect to your file system together. So if you are actually installing FS, like as an NPM, you won't see that FS inside that node modules. It will never come to your client side. It stays on the server. Advantage, right? So this is why the React Server component is something that we all of us need to kind of look into, should adapt to, and try to understand like how we will be using this one. If you want to try to do something with a kind of pure virgin React instead of Next.js, doing some application, please go ahead and do. You can still do it, but you have to like take care of some of the low-level things. That's the reason this application was built using Next.js, which you can access publicly. So far, good. Okay, so now I'll go back to my PPT once more. It doesn't have much more. It's almost done. Okay, I've showed this slide already. I'll just do a recap. So one of the things with server component, what we understood is like backend access without any round trip. So your client server, all the detach happen, components move to the server side. Then there is no waterfalls that we understood, like there is no waterfall concept at all. Automatic code splitting, we understood that, and because of that, we also have like zero bundle size. So it means that whatever I'm using as a server component, none of those dependencies impact the components also coming to the client side. So it is a good lifesaver. Of course, you don't have any access to event handler, state, and things like that. The moment you need that, what you need to do, you need to create a client component. Okay. So this is where one of the principle comes when you use server component. Push your client component towards the leaf. Make your server components towards the root. Why? Because you can actually get as much as information at the server component level and can pass those information through props. Down, 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 and then wherever you have to handle the handler and all, at the leaf level you handle. Okay. Okay. This is a constraint. Of course, the constraint makes sense. If there is a React server component, can import and render any client component. We have seen that, right? If you're a server component, it can actually render any client component, and it can actually render, because add client was a add course was a client component, right? We have imported it and the button came. But the reverse is not true. Why? Why can't you import a server component inside a client component? Quick. Because server component stays in server, client component stays in client. The server components never ever travel to come to the client side. It doesn't make any sense, right? However, whatever the computed data out of your server component, because computed thing is ultimately what can be serializable and understood by browser, that computed part you can actually send as a props to your client component. Okay, that is one thing. And then use client component as much as possible at a leaf level. I already told. So these are the things that I just wanted to recap. Hope you understood. I'm almost done. I just want to take a couple of questions, but before I end, a couple of things. My presentation is done. My talk is done. As a founder of React Play, I want to say like we are running a hackathon. It just started yesterday, the registration. So if you are interested to participate, please go ahead and participate. I'll be here. If you want to know more about this hackathon, please let me know. I can get you onboarded. And the second thing that I want to talk about is like if you like my work or the way I teach, you can come and join me on my YouTube channel. Okay, so that is another thing. And then subscribe or whatever. And thank you very much for listening to me with a lot of patience. I just any questions? I didn't answer. I didn't tell one thing knowingly that I'll be expecting as a question. But if there's no question, I'll probably answer that.
Hello. Yeah, we have one question at in the Slido. How React Server components are different than traditional SSR apps?
See, I had this question in mind. Yeah, so I think this is a normal, very normal question. Whenever we talk about React Server component, the SSR come into picture. How many of you know server-side rendering? So in both the cases, the word server is very confusing, but these two are completely two different things. And good part is like they can be used together. So what is SSR usually? The server-side rendering is you don't want your initial load of your application to be very slow. So something that you want to really compute and make a complete HTML ready at the server side, and then you can kind of push it at the client side. SSR stops there. After that, everything that happens is the client side component. Okay. Now you can actually build an application where your front page is like a marketing page. There is really nothing that you have to deal with the database. There is no interactivity. It's just some kind of text and things like that. And if you want that page to be loaded very, very fast, go for SSR for that page. Next, you need some data from the server side. Of course, you need data. Everything cannot really put it in the client side. Then there you go for your server side component. Then on that, you need some interactivity come for your client side component design. So both can be clubbed together. Hope that answers the question.
Yeah.
I hope you can hear me. Can you hear me? Is this working?
I can hear you without that.
Cool. So my question was like you touched on the part about cost, right? And my question is really, I'm just curious to know. Let's say when we are talking about server-side rendering and everything else, and even putting everything on server in case of server components, there's one inherent problem, which is that let's say when I'm using client-side rendering, I have CDN, which is available for free, Cloudflare, Cloudinary, any other thing, right? But in case you want to offer server components or server-side rendering, you need edge compute. You need computing on the edge everywhere. And generally, let's say I just want to host my portfolio and I have one server. I don't want to pay a lot, of course. Let's say I have one server and the availability zone is UST East 1. So what is happening is that, hey, someone from Bangalore, India, they're making a request to US. But now, since I'm using server-side rendering, I want to ensure that, hey, I want to reduce the latency, network latency, and everything else. So I'll clone that entire Node.js app or whatever in multiple availability zones. So first of all, I have to pay extra for that for edge compute. On top of that, there's another problem which is about round trip. Let's say we live in Bangalore and my server's in Japan now. And I'm making one request, Japan, and that Japan server is talking to my database, which is again in US. So that's adding to the round trip. Now, instead of that, what if I had a CDN and now from Bangalore, I was making a request to the nearest CDN, which is let's say Mumbai. And from there, I'm just getting the client side code. And then from Bangalore, I'm making that request to US database directly. That's also saving on the network latency, right?
Yes.
So can you touch a lot more about on that? Like how is that helping me in saving?
Yeah, so very interesting question. In fact, when React Server component came in 2020, I think it was COVID time, there was a video made by Dan and somebody else, I forgot the name, I think Clara. So in this video, he told that as a software developer, we can control 2 out of 3 things. So there is a cost, there is a user experience, and there is a say maintainability or things like that. Or the flexibility, we won't be able to control probably everything, right? We have to really pay for something. So if we want to really want the responsiveness to be very good, we want the user experience to be very good, and you want to adopt things like server-side rendering or the server component, you have to pay somewhere. You have to actually shell out somewhere. The shell out part could be the cost. So you have to probably pay cost for your server. You have to probably pay cost for your, like, what kind of traffic that coming to the server, and kind of manage it. It is a given truth. So it is something that you cannot really deny from the context of React server component. Like it is a server component, it has to reside on server. There is no other options. But you have to tally like between what exactly your gain versus what you're losing. Maybe you are having a customer. Again, the entrepreneur things comes into my mind. You are having a customer who is really paying you enough for you to and the customer, if you can make the customer happy with the user experience and things like that, the customer is going to pay you enough to take care of your maintenance and things like that. You don't mind too much because this cost is kind of covered. But if it is like, no, this is something that you have to really shell it out, you have to balance it out, you have to think about a lot about the server cost and things like that. You have to think about your approach, like, should I really go for that particular approach or not? So this is a trade-off that we need to think at the design level, and what kind of environment that we are operating with. So for any large customer, any kind of bigger customer that I'm kind of going through, who has the capability of getting me into Versal environment, they are okay with that, paying that particular maintenance cost. In return, they are getting really good usability and things like that. Of course, I won't mind implementing REST server component at all. And coming to your second questions, yes. So it is like the co-location. We have to also design like what exactly co-location means, right? So if you are dealing with file system, server's file system, your server component can be in China where your server is there, but your database is in Amsterdam, and you are actually dealing with things like the database query and things like that. You can deploy your server component appropriately, like where exactly the data store it is looking into. So you can actually do that.
That clarifies my question. Can you put that in?
One thing I want to ask, like, is the RSC is about like if I'm visiting some home page and it has got some 3 other tabs. So is it like hinting to the server that there are 3 other pages and it should be dynamically processed on the server side? And as soon as the user clicks on the second or third tab, so it should get loaded. Or how is it like data organization between these pages, like which RSC?
So how you should think about is like, do you all believe that all the developers also need to wear designer hats some of the other time? You believe? Yeah, I believe it strongly, because otherwise the product fails. So when you are in the design phase, or you're sitting with the designer, I think these thoughts come only on that time itself. It is not about the designer giving you a page or the interaction points, and then you start thinking like whether this is going to be a server component, that is going to be a client component, how my hierarchy is going to be. So at the design phase itself, you can think about saving cost, you can think about maintainability, and think about all these aspects. So for example, for your point, if the type, of course, 3 tabs are not shown at a single point of time. 1 tab is shown, other 2 tabs are not shown. If the titles of those tabs are not fetched from the server, right, and there is no interaction point with the database for the title of those tabs which are not shown, I probably won't make them as a server component, because they might have some kind of client interactivity, the button and things like that on them. But if the content of those tab has heavily dependent on data, they need to kind of query data, they need to like request and response, I'll definitely make them a server component, because that will actually save me all this latency and all these things. So think from the perspective of how do you want to design, keeping these considerations in mind. Okay.
Right. So we also have a few more questions on Slido, but as we are on top of the time, maybe we can take them towards the end.
Okay, sure,
Yeah.
sure.
So it would be great if you can also upvote everyone. So, and for now we will mark them as answered, but we'll bring them back towards the end of the session.
Sure.
Thank you so much, Tapas. A huge round of applause for a great session. Next, we have Tanisha, who will be talking about Tailwind. How many of you have used Tailwind before? Okay, that's great. And how many of you have, like, you are proper into front end? Like, okay, that's great. How many of you are in back end? Anyone? Okay, that's great. Yeah. So we always struggle to find backend speakers. So that's a small plug, everyone. If you would like, please feel free to come forward. So we'll have, this is the last talk of the day. But as we say, right, this is the end. This is not the beginning. So please feel free to utilize this time live. Ask your questions away, and also after this session, we will have I think at 5 p.m. you will receive the automated email from Meetup to provide your feedback. It would be really appreciated if all of you do that while you are in the venue. Yeah, all of you are with me? Yes? Yeah, so we should, with a huge round of applause again, please join me in welcoming Tanisha. And yeah, so please. So while Tanisha is setting up, Tapas, would you like to share one non-JavaScript side of yours?
Okay, what is this question? I mean, what do I do about from JavaScript? Yeah, if I'm not writing JavaScript, I probably write, uh, on my blog.
So I guess it's on the extend, so we can, yeah. Do you want to move it to the screen? Okay.
Okay, so hello everyone. I am Tanisha. I work as a senior software engineer at Gamescraft. I am also one of the organizers of React India and JSConf India. So you might see me around there. I'm so sorry for my sore throat, but let's do this. So we'll talk about a much controversial topic for all front-end devs out there, Tailwind. So from whatever I've experienced and from whatever I've talked with a lot of front-end devs, this is like a much controversial topic as to should we or should we not use Tailwind. So let's just cover it as to why people don't prefer it versus why people prefer this. But before we jump on to understand more about it, the question is for everyone to set up some context. What is Tailwind? So you can imagine Tailwind as a framework, which is a collection of smaller utility CSS based classes, which you can plug and play together, build it up, and build beautiful UIs faster. So, Adam, the author of Tailwind in itself, says that usually naming these CSS classes is harder. So, these utility classes help us in bringing up the UI together. So, for example, how we traditionally write CSS is more like a use case sort of approach. Say you have a button, you have a drop down, you name it, and you give some styles to these classes. But instead, in Tailwind, what you do, you pull up these utility classes together, make it together and build a UI out of it. So you can think something like this, where you have a div, you start appending these smaller CSS utility classes to build certain UI. You can also have breakpoints for your responsive styling, and that will build for all classes. Then you have states, so you can bring it up all together and create any UI that you want. So a quick show of hands of how many of you have used Tailwind. Okay. How many of you have not used Tailwind, but maybe just heard about it? So, and how many of you have gotten into a fight as to should we or should we not use Tailwind? A very slightly somebody pulling up their hands, but I think most of us have had. Now, quick context. This was back in lockdown. I was in one of the spaces with Neha, who is the founder of JSLovers. So huge shout out to her for uh, bringing us all together. And I think before that, I had not used Tailwind. I've just heard about it, all the opinions around it. And my opinion about it was very different. And I realized it later that was because I had not used it. And that's when I went back, learned more about it, and it changed things for me. So this presentation will sort of cover that. So the question remains, why the hate, or rather why people not prefer it? The number one remains, it makes the code hard to read. But not just the code, I think it also makes the PRs hard to read. So all of us struggling with reviewing those PRs understand it. If you see, this is a small checkbox from the Netlify dashboard, which has so many of these CSS utility classes appended. So, okay, fair point. Next remains, it locks you into a utility CSS paradigm. So, why people do not prefer it is remains is maybe what if Tailwind does not exist tomorrow? So, how can you do it without it? You will have to change the entire code base. So, that's another con as to it locks you in the paradigm. Some say it's an unnecessary abstraction. So, here by abstraction, they mean that since you are appending these smaller CSS utility classes, previously how we use the use case approach, say it's called button, the class name identifies what it does. But with CSS utility class, you abstract the way a component's supposed to behave. Again, the counter to it might be you can use apply, but the next debate comes to should you or should you not use apply. So that's for another debate, but yeah. And the last one, it's wet, not dry. So dry means do not repeat yourself. People usually see it as a repetitive CSS usage than not uh, than not repeating again and again. So, how many of you again have not used Tailwind? And how many of you have not used Tailwind because just you didn't like it? You didn't like as to how it was projected or as to how you heard about it over Twitter, over blogs, over Medium. But for those who did not use it because you didn't like it, have you heard about this article? Have you read anyone? If you have not, you should definitely go it because it teaches you much more about life. So I would say give it 5 minutes. Uh, what we love as devs is to jump onto conclusions and make very strong opinions about different things that goes around. But I think everything, give it 5 minutes or give me some time to maybe change your perspective if it's the otherwise. So this happened with me also, and I went back to read about this article that the author of Tailwind had written. It's more about CSS utility classes and separation of concerns. Separation of concerns isn't as complicated as it sounds. It just means that you should keep your HTML and your CSS independent, and it should not depend on each other on the structuring. So he talks about how we have traditionally written CSS, right? So say suppose you have a paragraph and you want to give certain style to it. So what you would do is you will give it a class name, you will assign some styles to it, and you're good to go. But say suppose the component structuring is such that it forms a nested hierarchy. In that case, if you use something like a preprocessor, you will start depending on the structuring and you're not following the separation of concerns in that case, right? So what do you do in that case? You decouple your styles from your structure because you don't want each of those to depend on one another. So say suppose you have a structure like this, and this is more like a BEM approach that we have. You give different class names to each of these components, assign names, and go on. But again, what if these styles are to be used somewhere else, right? So instead of using author class names, you would give it a generic class name, say media. So you can use it at two different places. But what will this do is, aren't we mixing concerns now? Because again, you are depending on the structure and changing the class names otherwise. So the problem with this is separation of concerns is not black and white. It's not. It is black and white. You can either have it or you cannot have it, and there's nothing right or wrong about it. The problem with us when we are debating as to we have to use something or not, we get too attached to the definitions, and that's why I came across this article where it says This definition is an extreme and ultimately very warped vision of what it means. So, what do we do in that case? Maybe use a content agnostic css. Say suppose you have a button and you have different variants of button. One is primary, so you give it a more content agnostic name, say primary button, which is used to behave in a certain way, primary, secondary, and so on. But we combine it with utility css, so the variant remains primary, but it can behave differently in different scenarios. Say if it's on the right hand side, you need to give some left padding and vice versa. So you combine it with utility css, and you give it those small utility css class, and you're good to go. So you're combining both of these, and that's where utility first came into existence, and that's how Tailwind was born. So the question is now, can we like Tailwind? Let's see if we can. uh, so why would you prefer using Tailwind? I think after I started using it, changed things for me. So here's what people said after they used, and it's a combination of my experience with it. Let's go back to the points that we had as to why people don't prefer it. I think one of the main reason remains it's harder to read. But what about a CSS, right? We often crib about our HTML being bloated or HTML becoming unreadable, but so is our CSS at most times. We have so many of these unused classes lying around there. So, how many of you have those CSS classes that you haven't used, but you're still there and you don't want to clean it up? One example remains from the CSS Tricks website, that if you see the usage here, it's very underutilized in terms of the CSS file. So again, right, the CSS does become bloated. It's either or. So it's not really a valid counter. But again, I would say that it has a learning curve. Usually, people don't like using it because they haven't gone through the learning curve. They find these semantics hard to read and so on. So I would say give it some learning time, and you would see the difference in whatever opinions that you had previously around it. The second one, it locks you in a paradigm, but maybe it might enforce consistency on the other hand. So if you see these websites, GitLab, Buffer, Help Scout, they have so many of these tokens, your design tokens, which might include colors, spaces, and so on. What I liked about Tailwind, especially for smaller projects, was it enforced consistency in terms of using these tokens. So I was enforced into using certain tokens that I have instead of picking up any random color hex code and using it my CSS. So again, right, it's a trade-off that I liked. Abstraction. It's funny how we love to talk about abstraction, but we still abstract the way about the concepts that we use. But again, like I would say, if this abstraction helps me in a way to build up UIs faster, maybe I'm okay with that abstraction. Abstraction is not always bad. It can be an abstraction that I am okay with for the trade-off that I'm being made. So, how many of you remember this book? And how many of you have read this book by Robert Martin? So, if you have, you might remember this very interesting chapter, how to name your JavaScript variables. And I think naming CSS classes is equally hard. So, how many of you, when you're writing CSS, took a 15-20 second break just to think of the perfect CSS class name? So, I think that it's one of the things that I like, that I don't have to think about it anymore. But again, right, coming back to the point of to having strong opinions about a framework. So the points that I covered as to why devs don't prefer it, somebody on the Tailwind GitHub issues mentioned the exact same points as to why the person likes using. Again, it is a very case to case dependent basis. There's no right or wrong of using it or not. It's more dependent on the project that you're using for. In certain cases, again, Tailwind might not be the perfect approach, but in certain projects it might be, because of the faster shipment and so on. So the question remains, what worked for me, right? After all this, why would I prefer using it? For me, it worked because of the speed. It helped me build UIs very fast. It was very easy to pick up. So I know a lot of backend devs around there. I have worked with people in smaller projects who might not be very well versed with the traditional semantic CSS, but they were very quick to pick up the entire terminology that this had after the initial learning curve was over. So, again, this. And finally, the community. So, say, suppose you have a smaller project or something that you want to build faster, the community is amazing. You this is one of the examples that we have. Tailwind components is a repository that you have with every components that can be made with Tailwind, so you can just copy and paste, and we know how much we love copy pasting, so it helps build those UI faster. So now the question remains, what about performance, right? You would think that is it the trade-off that I want to do and take a hit on my performance? But again, I think Tailwind knew exactly what they would be called out for, and this is what they mentioned on their homepage at the right top. So whatever uh, CSS class you're referencing to, whatever utility classes that you're referencing to when you're using Tailwind, it only bundles those in the production build. So it purges any unutilized utility classes. So again, right, it it helps, it is a trade-off that we can take. So now the question remains, do you love or do you hate? Again, at the end, it's a very case to case basis, and the end line or the bottom line remains, your users don't care about the CSS drama. It's much more about what works best for your project, what works for your end goal, what works for your end product, and it does not matter. So thank you everyone. I hope you had a great time listening to it. Any questions?
Thank you, Tanisha. Any questions, anyone? Yeah, we have one from Sanket. Yeah.
Okay, so I think I will go back to what worked for me better. Is again, for smaller projects, I love that I don't have to go back and forth when using when using Tailwind. It helps me just build UIs faster. But maybe for a project where I have to use a lot of animations, then Tailwind might not be a good approach, because I cannot perform those complex animations and so on. Some other endpoints, like for a larger project, one point that always comes up is Tailwind does not allow code splitting. So you will have a lot of underutilized in a larger project. So again, that's one con. So I think it will more depend on the project that I'm using, but in the end, it does not matter.
Anyone else? That was a great talk, everyone. Yes?
Thank you.
Yeah?
Thank you.
Thank you, Tanisha. So any guesses what we have next? Yeah. So are you excited to win something? And more than that, learn something. Yeah. So when we had this quiz, similar quiz at the React Nexus, it was purely about React. This one is more about JavaScript. So yeah, so most of the questions were like it started a conversation among the participants. So let's see. We have Smile, who will be hosting this quiz. So over to you. So everyone, we need some action from your side. We will have a QR code which all of you should scan. So you can take out your phone, open the camera or Google Lens or anything else.
Maybe seeing the price will charge up your battery and you will be energetic enough for the quiz. People are still joining. Only I see 5 participants and we have a room full of people. "49 participants who have not registered, who don't want to try their luck to win some goodie." See, Tapas is already ready. I am ready with all the questions. I am pro in JavaScript, so I will win a goodie home today.
61. Come on, let's everyone get on board. 63. Yeah.
10 more seconds. Join people. Anybody who's facing any difficulty scanning the QR code or signing in? Internet issues? Okay, please. Anybody else facing any difficulty?
Share button on the top. Give the QR code very big to
Sorry? Sushil? They're getting an invalid code.
Huh?
Invalid code.
It's Q3. That's a different one. Go scan that.
We are just starting in a minute. Somebody's having difficulty. I hope now it's visible. Avian people, anybody who has still not registered? I see one person.
We can start.
Yeah. So I'm starting with the first question. The question is coming in 3, 2, and 1. Here's the question. Upon encountering empty statements, what does JavaScript interpreter do? If you don't know the answer, just hit it fast. The one who enters fast will get more points. 20 more seconds. If you don't know, just maybe randomly inky pinky ponky and you will get some answer. Sorry. I know now. I should have kept it less. Okay. the explanation is the interpreter will ignore the empty statement whenever it encounters them. Let's move to the next question. Next question is coming in 3, 2, 1, and the question is here. Which is the following scope type of JavaScript use? Very easy one. I don't whisper the answers, please. So it will, at the end of the day, impact you only. I hope by now you would have even discussed with your partners. I should have kept the timer a little less. Oh, ChatGPT. Nice. Okay. Still, there are still more people who have get it wrong. But yes, JavaScript have lexical scoping. Let's move to the next question. The question is coming. 3, 2, and 1. The question is here. What is the prototype represent in the following JavaScript code snippet? Just take a minute and think. It might not be the straightforward one. First option not valid, then prototype of a function, then functional JavaScript, and a custom constructor. Cool. The correct answer is custom constructor. You can see the explanation here. Moving to the next question. And the question is coming. Very easy one. Why event handlers are needed in JavaScript? We already have a big talk on from Tapas, which emphasizes on event handlers. So it allows JavaScript to alter the behavior of the windows, then add inner HTML page to the code, then change the server location, and last but not least, perform handling of exceptions and occurrences. Are you ready for the answer? And yeah. So it allows JavaScript to alter the behavior of the windows. Next question. How do we define the term thread? Is it device that controls input, variable that controls movement, controlled execution of applications, device that controls input and variables that controls movement? And the answer is here. Controlled execution of applications. Next question. It's loading. Page refresh. Okay, let me try refreshing the page. Okay. I'm moving to the next question. Okay. just try to read the statement. Which statements are true? The render tree contains all the elements from the DOM and CSS OM combined. Composing is the process of separating layers based on Z index, which are then combined to form a final image displayed on the screen. The layout process assigns colors and images to to the visual elements in the render tree. The compositing process happens only on the compositor thread. Elements that are not visible on the page, for example, display hidden, are not part of the DOM tree. That's a long question. I have posted a long explanation if you want to read what was the correct one. Okay, one next question. It's a quick, it's a short one, I'm sure. What does the handshake pass between the browser and the remote server? If I would be in the place, I would have done Inky Pinky Ponky because I never read this computer networks properly in my college. Last 1 second. Yeah. Oh, nice. 37 people knew its correct answer. Moving to the next question. How can we define the term performance? Speed of the input that takes in, speed of the output displays, speed at which application functions, or the speed of data transmission. What is performance? 10 seconds, people. Yeah, that is a speed at which application functions. Next question. The second last question, gear up and try to answer it quickly. Oh, no, it's a big question. Okay, yeah, and you need to put the scripts in the right order of execution. So the first script that have a sync keyword and that loads in 300 milliseconds. Then you have a defer that loads in 200 milliseconds. Then you have another script with defer again with 300 milliseconds. Then you have a sync script that loads in 50 milliseconds. And then last, the bouncer, you have a script that have async and defer both. What do you think? It loads in 60 milliseconds. Wow, 9 participants had this correctly. There is a trick part here. This async and defer, when you use with the in JavaScript, it behaves differently in old browsers and it behaves differently in new browsers. So maybe people who have answered wrong, that could be a thought. Okay, the last question. And it loads in 3, 2, 1. And the question is here. In how many modes can a closure compiler be run? 2, 3, 4, and 5. If people don't know what is a closure compiler, maybe go back home and read about it. Okay, I'm ending the quiz. And let's see the leaderboard. Okay. Yeah, nice.
All right. I think we need some JavaScript devs.
Correct. TM. Okay, let me open the. Sorry. Okay, wait, I am just trying to see. Oh, yeah.
All right.
Oh,
We have Supriya. A huge round of applause for Supriya, Shreyas, and Dan. Yeah, please
oh.
join us on stage. We would love to have a picture.
Yeah,
Yeah.
we have. Who is Dan in this room?
Yeah, who is Dan? Is Dan is? Oh, you are the Dan. I almost thought it's a bot. Yeah, yeah, I think it would be great. Round of applause, everyone. They did great. Yeah. So, Right.
We have some special goodie for the one who topped the leaderboard.
yeah, Dan. So please stay behind.
Here you go, Danish. Some goodie for you.
Okay, Danish. Thank you. Claps, everyone. So,
Yeah.
so we are towards the end of the session. How many of you learned something new today? Let's see the show of hands. Amazing. And how many of you would be joining the next meetup? That's great. And how many of you would try submitting a CFP? Take the action. Okay, that's great. Awesome. So we will very soon you will receive an email. I think it's already past 5, so you must have received an email. It would be great if you can submit your feedback on the meetup, and you can also share what topics you would like us to cover so that we can find the speakers for those. And a huge thanks. Thank you to the entire Geeky Ants team. A huge round of applause for them for hosting us. For hosting us here, and it's been an amazing day and venue here. Also, would love to request all the speakers to join us on stage. We will have a quick picture, and then we can call it a day. So all the speakers, yeah, it would be great. Everyone, we can thank them for the time they took for preparing the presentation.